Hello everyone, my name is Kalathiya, ID number PCM24142, pursuing my Masters in Construction Engineering and Management at SEPT University. I will be presenting my integrated construction practices portfolio developed as part of the CM4001 studio. My work focuses on a high-rise commercial project. So coming on talking about the project, here is the project information given where the project is a greenfield commercial development with an estimated cost of 482 crores consisting of a G plus 18 structure and 3 basements with 338 office units and 63 showroom units spread across a built-up area of approximately 76,940 square meters. So for this studio integrated construction practices, the project scope was taken as first basement, basement 1 and the fourth floor. And here is the plan shown where the building has been divided into two posts, part A and part B. And the project timeline has been given starting from the 6th of April 2023 and ending on around 31st of December 2028. So talking about the roles and responsibilities for the studio. Additionally, as a part of the structural and electrical consultant roles, responsibilities included preparing LOD 300 and LOD 400 BIM models, handling RFIs, performing clash detection and process mapping. So here is the estimation given where the quantity takeoff was been done as part of the exercise, where the comparison of the manual and Revit quantities, generated quantities for major structural elements, columns, beams, slabs, and reinforcement were been taken. The key observation was that the Revit captured geometric details more accurately. For example, slab quantities in Revit accounted for openings, whereas in manual calculation these were overlooked, leading to higher manual values. This resulted in variations. For instance, the fourth slab quantity varied by 12.69 cubic meter, which is 2.86%, highlighting how manual methods can easily accumulate errors in repetitive calculation tasks. So here is a comparison given where the difference has been shown for the Revit and Revit quantity amount and the actual quantity amount. And here I'm showing the architecture model quantity takeoff comparison between the manual and Revit quantities. So a similar comparison was carried out for AAC blocks, walls, doors, windows, and ventilators. So here there was a different scenario where the discrepancies arose mainly due to the modeling errors and manual calculation mistakes, especially in incorrect wall thickness modeling, where the layout had been changed, the design had been changed, where the 115 mm of the wall was modeled as 120 mm beam that was not detected in manual 230 mm wall calculations, where the beam depth and the clashes between the doors and the walls had been seen, where the height of the wall didn't catch up as per the beam depth. So here that comes down around the difference between the Revit quantity and actual quantity being given here as 30,974. So by quantity takeoff, there can be from the Revit model. A BOQ can be generated. So here is a BOQ that has been presented here, taken from the Revit model. So here the unit quantity and unit rate and total amount are been given for the structure elements of the basement 1 and 4th floor, which were been taken from the Revit model from the quantity takeoff, and where the unit rates can be put to get the total amount of the quantity which will have to be taken for sure. And the unit rates were decided as per the ongoing rates on the site and also as per the market. So the description has been given here, where the structure column shear and lift walls of M50 grade and M40 grade for the different elements and the reinforcement steel have been given here, where the unit for the how it has to be measured, in what quantities has to be measured for the quantity of the concrete. Cubic meter has been taken into consideration, and for the reinforcement steel, the ton has been taken into consideration. So next on coming upon the site layout optimization, here is the 3D render being given provided for the current site layout, where it highlights the different areas of the site layout of the cafeteria, scrap yard, bar bending machine, bar bending and cutting machine, block storage and shuttering storage with the entry been given where the site office is been located. So here the main critics of the site has been listed where the problems were being faced and the routes also the for the current to change the current site layout to give better efficiency for the in the further site layout. So the critics here are there was a single route for pedestrian and vehicular movement. So here for the entry they had actually there were two entries on the site where only single entry were being used with causing risk on ongoing construction where the labor movement and the vehicular movement were from the same path and which might cause and may cause any accident. So for this was the critics this was the critic had been taken in mainly into the consideration, and for here is the improper storage of material been given. So as for the improper storage of material, the materials were being located far away from the scrap yard and the bar bending and cutting machine, so which also reduce the efficiency where the material had to be taken from one point and taken to the another for the bar bending and cutting, also for same as for the shuttering. So the location of QAQC lab was far on the corner of the site, which had to be changed for as when a documentation is being needed, and also the location of the QAQC lab was far away from the concrete pump, where the material when needed to be tested or needed to be taken, a sample has to be taken. A labor has to travel a long distance to get the equipments or the QAQC equipments to take the sample. So the location of machinery was also taken into the critics where this two bending bar bending machine were been located in two different locations where the cutting machine and the bar bending were located in the different location, and the location of the scrapyard here has been given was located far away at the corner of the site far opposite side of the entry. So when a scrap had to be the scrap had to be transferred or taken out of the site, the vehicle has to enter to the corner of the site to take out the scrap. So it will cause a disruption when a construction practice has been going construction is been execution has been going on. So here is a site layout comparison given of the current site layout and the proposed site layout where the locations were being changed. So coming on for the QAQC lab, the current site layout shows where how on the corner of the site it's been located. So so here is the near the crane there is a concrete pump. So a labor has to travel from that pump to the QAQC lab and take a go back to the pump to take the sample of the material. And as for it's also located far from the site office where any document needed regarding the testing material or the quality assurance report, a person has to travel from the site to go to the QAQC lab to take the documents regarding the quality of the materials. So here the toilet was also been shifted. The toilet was relocated on near the entry besides the marketing area of the site where the entry was situated. So which gives a foul smell. Also the labor colony and toilet area were being located in two different locations. So when in the morning or during the execution has been going on, during the working on the site has been going on, labor travels from the within the site to the toilet, to the washroom, to the bathroom, where the safety is been taken. So there is a high risk of any accident to appear or happen on the site where a labor without any helmet or safety jackets has been traveling to go to the toilet or the bathroom, which could cause any accident on the site. So for the safety of the laborers and safety of the staff, the toilet was been situated near the labor colony. So here is the steel yard and bar cutting and bending machine located on the current site layout. So these were shifted besides each other, where the steel yard and the machine was shifted both beside each other, because due to which The material from the steeler had to be carried to the bar cutting and bending machines. So they were located together as to avoid any traveling or and avoid any accident to appear and cause any interruption between the through the execution on the site. So the labor colony was shifted on the corner of the site besides the toilet. So the labor had very much better access to, all over the site. So here is a scrapyard where looks shown in the current site layout. So the scrapyard was being located in the corner of the site opposite to the point of the entry. So which was been located near the entry where any vehicle comes to take out the scrap. It won't enter into the site. It will just pass from enter from the enter in the site and take it from there itself, and it won't disrupt any ongoing process. Also the safety chances will be better, and to also avoid the vehicular movement, less vehicular and pedestrian movement does not clash. So here is a POT analysis been given of the on the current site layout. So for the POT analysis what? Path of travel analysis, where the main components where the efficiency gets lost due to the traveling and the location of the other site layout. The components where the as shown on the critic side, the QAQC lab to the RCC pump. So this was the time calculated and taking on the travel speed of an average travel speed of around 4.8 kilometer per hour, and the length was calculated as per the distance from the QAQC lab to the RCC pump. So here was the time consumption being shown, and same as for the labor quality toilet and shuttering storage area to cutting area with scrapyard to the gate. So the time will be calculated for the traveling from that one point to another. So as on changes from the proposed site layout, we have seen that the time gets reduced. Time gets reduced here, so it gives a better efficiency, a better workflow on the site, which mainly gives a better idea, a better efficiency, and also it also gives mainly the safety of this. So for the here has been shown the site entry of other movement for the pedestrian movement was been opened. So the second entry which was been closed was been opened for the pedestrian movement, and for the first site the entry was for the only the vehicular movement. So here is the path of travel analysis. So here the current and the proposed comparison has been given here regarding the traveling time of the on the site. So major efficiency gain achieved by relocating the cutting and bending area closer to the material storage, and also when so here has been given the longest travel route reduced from 95.03 seconds to 7.88 seconds. A 91% of reduction was been seen. The formwork to cutting machine movement dropped from 57 seconds to just 2.4 seconds, eliminating unnecessary labor fatigue and delays. This proves how an evidence based layout can transform on site productivity. So here the cost of rework from the current site layout to proposed site layout, if the current site layout has to be changed, so what will be the cost of rework that will be needed for to execute the proposed site layout? So that comes around 16,100 rupees for the cost of rework. However, despite the low cost and high benefits, site conditions did not allow immediate implementation due to ongoing work and lack of space flexibility, a practical constraint to consider in real project management scenarios. So concluding on with that, so here what was shown that the quantity takeoff and the BOQ preparation which had been done is a very much effective process. as the quantity from the Revit model comes accurately. It has a precise quantity, gives a precise quantity which can be used on the different phases of the execution on the site, when material has to be ordered, or the material has to be the material the cost of the material is been needed. So where at different phases that could be checked from the Revit model from following the quantity takeoff procedure on the Revit model. Also, a BOQ can be generated very much easily as per the elements that are used in the on this will be used on the construction process, and the materials that will be used. BOQ can be generated very much pretty effectively. Also, in quantity takeoff, an estimated, or let's say precise quantity will be given by the Revit, which also gives a better efficiency and better precise quantity. So for the site layout optimization, so here in the site layout optimization, current workflow pattern can be seen, and the decision for the propose and for the decision for the changes in the site layout during the phases of the project can be efficiently used through the model. Through this model, efficient changes can be done, and also uh, to avoid the routes which take a longer time, to avoid the location of the particular buildings or temporary structures that have been set up on the site for the execution of the project, that can be managed in a very better way, where the efficiency of the site increases, where the labor and the staff gets to coordinate very easily, and also an improved layout enables smoother workflow transitions and fewer operational delays, and a strategic way of approach can be seen, for which also the cost of rework can be taken into consideration through the site modeling on the different stages of the project, and the safety of the labors and the staff can be taken into consideration depending on how the temporary structures have been set up on the site. And so from this I conclude that the ICP approach both of these exercises is pretty much good for the change in the construction industry, which will give a better efficient and a better accurate results for the execution of the project. So thank you.